Hello and welcome. My name is Michelle Bogdan, and I am a STEM education specialist with Vivify STEM. In addition to my work with Vivify, I currently work at NASA in the Office of STEM Engagement and am a former science educator with 9 years of classroom experience. Today, I am excited to show you how to captivate your students with a hands on demonstration that will have them at the edge of their seats with excitement and curiosity, while also providing tools to incorporate quick demonstrations into meaningful STEM units. Let's get started. I like to start this demonstration with a simple yet engaging question. What did you eat yesterday? Then I ask, do you think this is a good menu for an astronaut? Why or why not? This question sparks a lively classroom discussion as students start thinking about their food choices. I ask them, what are some of the common characteristics you notice among the foods you listed? Are they primarily fresh, cooked, packaged, a combination? Are these foods nutritious? How could we figure out how nutritious food is? What is nutritious? Using their ideas, we define what makes food nutritious. I summarize the key points on the board and guide them to understand that food is energy. The understanding sets the stage for the next exciting part, seeing how burning food relates to its energy content. But remember, they don't know this yet. They don't know that we are going to burn food. So keep them on the edge of their seats. With this foundation, I hold up Cheerios, marshmallows, and peanuts. And I ask, if food is energy, which food item do you think will provide the most energy? This question ignites their curiosity. We discuss predictions and the reasons behind them, whether it's sugar content, size of the food, or nutrition labels. However, the real challenge comes when I ask, how do we find out? How do we find out which item provides the most energy? This sparks a 10-minute or so. Give your class time. It might be 20 minutes. You might extend it out longer, or you might guide them a little bit more. But a 10-minute or so brainstorming session where students propose various methods. My class was deeply engaged in this portion, bouncing ideas off of each other until somebody suggested burning the food to measure its energy. They made that correlation between burning calories, going on a run to burn calories. They were able to make that connection, and I did have to guide them a little bit. Sometimes they'd bounce the idea, and then someone would grab it and go a different direction. So teacher guidance is needed in this portion to get them to that idea that burning the food can measure its energy. I did this experiment and demonstration with an eighth grade science classroom. So, this demonstration can be used in many different age ranges, and the guidance and support that is needed will depend on the student's level and previous knowledge. Now that you've hooked your students on burning food, it's time for the demonstration. Let's talk a little bit about the prep for the demo. Before starting the demonstration, I recommend getting it prepared ahead of time and testing out the setup a few times before you are in front of your students. With advanced or older students, you could even set this up as a lab in small groups. Therefore, preparing all of the materials for the students will lead to a smoother experience. Many teachers may be familiar with a calorimeter lab or a calorimeter demonstration and know that there are several ways to set this up to be successful. It is very adaptable with supplies you may already have in your classroom. While there are pros and cons to different setups, The setup I will provide for you today was designed for students to easily visualize the demonstration from their desks. The con of this setup is that during the burning process, heat will be lost as it is not contained, leading to possible errors in the results. My overall goal was for them to make that connection that food is energy and they could see it. So I wasn't too concerned if the numbers lined up perfectly, but more of grasping that understanding. To get started, you're going to need a few materials. You're going to need a ring stand clip, tin or aluminum foil for the food to sit on. I used a small aluminum foil pie tin. Copper or aluminum wire, non-coated, approximately 45 centimeters. A soft drink can. You could remove the top of the soft drink can using a can opener. A balance. I used a triple beam balance because that was a skill we were practicing in our classroom, and I was able to have students measure out the food using the triple beam balance and practice along the way. But you could also use an electric balance. A thermometer. We stuck to the Celsius scale, and our thermometer, we had to go back and get one that reached a higher temperature. So I suggest your thermometer be able to reach above 50 degrees Celsius. A graduated cylinder to measure the water. Again, a spot where the students can participate in this demonstration is coming up to measure 50 milliliters of water in the graduated cylinder. Rulers. We used a ruler to measure the distance the can was from the ground or the table. Scissors may be needed. Safety goggles. You should use safety goggles. Students should realize that safety goggles should be worn during the demonstrations. You will see I did a video where I was not wearing safety goggles and should have been, and there were no students in the classroom at that time. Butane lighter. I used a long nozzle so that way, you're not getting in the way of lighting the food on fire. You're not accidentally knocking it down. And the long nozzle, you're able to kind of stand out and hold it out there. And then 3 food items. I recommend using marshmallows, Cheerios, or peanuts. Those are really great options that we used in our classroom. But what you're looking for is dry, high-fat food. So peanuts may not be an option in some schools. So you want to keep in mind dry, high fat. One of the demonstrations I will show you in a little bit is with using a cheese ball. And that was a dry, high-fat food that burned really well. So other foods are able to be used during this demonstration. You may want to keep in mind that the food item has to either pierce a coil or be able to stand up on its own. So we'll see that in a bit. You can see in this image here, we have our ring stand with a clip to hold the can about 5 inches from the bottom. I bent the wire into a stand to hold the food item. So I created a little stand for the food out of the wire. I pierced the food item, so that is a peanut I pierced, or you could wrap the wire around the food and place it in the tin or aluminum foil. So in that example, I was able to pierce the peanut and it was light enough to be able to still stand up using the coil. I did tape down the coil. You can see a small piece of the coil was taped down so it stayed in one place. And another picture of the setup. Here you're able to see that this is after a burn example. The can has burn residue on it, which is fine. The coil, there's some burn residue in the tin. I have the graduated cylinder out and water to measure for getting ready. And again, this is the setup. And this is what you want to have ready to go before the students come into the classroom. It's prepared. They're able to visualize what's going to happen. All right, so we're back in the classroom, and now we've, engaged the students. We've talked to them. We've asked them questions about food, and we've figured out that we're going to burn the food. They can see the setup that you've prepared ahead of time. And at this point, you want to provide the students with a data table. And together, walk through the rest of the procedure. The data table will capture the mass of the food, the initial water temperature, the final water temperature, and the temperature difference. I wrote the data table on the board, and together we worked through to fill out each of the different areas. So now we are going to see the lab getting performed. So I am measuring out water and pouring the water into the can. So 50 milliliters of water is getting poured into the can. That is the cheese puff that we are going to use. The cheese puff is getting lit using the lighter. And there we go. We let it go ahead and burn. So here's an example where in the classroom, it would be important to make sure you have your safety goggles on and you let the cheese puff go ahead and burn. It will take a few minutes, 30 seconds to a minute to burn. The cheese puff has a really nice burn going. And you'll see in some of the other pictures, your students are captivated by this. They never would imagine that you would be burning something in the classroom. So a few things that happened before was we did measure the mass of the food item. So the mass of the cheese ball was measured and recorded. And then when the burn is out, I quickly was able to go ahead and check the temperature. So let's go ahead and watch that video one more time. So keep in mind the different steps that are happening here. We first are measuring the mass of the food item, attaching the food item to the coil. The coil's in the tin. We measure out 50 milliliters of water. That 50 milliliters of water, we do want to know what that initial temperature is, and we record that temperature of the water. We then light the food, observe the burn, and then when the flame goes out, we can record the water temperature again. Pour out the water and repeat for the next two food items, and be sure your coil stays at the same height. So those are kind of the steps that you go ahead and use for the 3 different food items. So we'll go ahead and watch that one again. Measuring the water, pouring the water in, and able to get an initial recording of the temperature of the water. Piercing the food item, lighting the food item, and then observing the burn. Each food item burns a different length of time. It will burn more than others. So again, that cheese puff is a great example to show the visual. Checking the temperature, and we are set. So here we can go ahead and see that this is an example of a marshmallow burning. We've got, I believe that is a peanut going there. And you can see in our classroom, I had the students still seated at their desk. They were not up close to the flame. They were at their desk area and were not allowed to cross a certain line. Here we are lighting it. So you can see I had a table out in front of the room with all our different supplies, multiple times for different food items. Able to light it, and we'll go back and see that one more time. I've got water out, graduated cylinder, the balance. I would call students up to use the graduated cylinder, use the balance. Here is another example of the setup. I believe that is the marshmallow burning. And I wanted to show this picture because you're able to see I have the data table written on the board. So we were able to kind of work together. The students had a version of the data table that they made at their desks. This could be pre-made. You could have them make their own data table. We had one on the board that we made. So it was a demonstration, but I was trying to have the students interact as much as possible. So they were able to come up and measure the water. They were able to come up and measure using the triple beam balance to find the mass of the food item. And then myself and my co-teacher were there to light the food items and make sure no one was touching any of the supplies that might be hot. Another picture of our table setup. And just some more photos. You can see the ring stand here and the clip holding the can. All right. So once we've gone through, we've filled out our data table. Students are going to be eager to interpret that data. So I asked them what happened when the food burned. So we talk about what happened when the food burned. We talked about what the data might tell us. So we haven't really gotten too far. We've recorded a lot of data, but we don't know exactly what this data means. And we've talked about how can we use the data to figure out how much energy a food item has. So we've seen the burn. We know that the burn means that there's energy, but we haven't figured out yet, how do we figure out how much the food had? So we introduced the concept of a calorimeter and explained the term calorie. Many students may have already heard this term before, but not as an energy source for heat. We talked about what a calorimeter was and how it measures the amount of heat given off by foods when they are burned. The heat is produced in a unit called calories. We use the information in their data to calculate the calories. To calculate the calories, they multiply the temperature difference by 50. When students calculate the calories, they will most likely notice that the number of the calories they calculated was extremely high for the small volume of food. This is important to address the calories with a lowercase c are different from calories with an uppercase C. The food calories we use are actually kilocalories. Converting calories to kilocalories is done to make it more manageable to communicate food energy. So this is something you definitely want to talk about with the students. You want them to make that realization. My class was able to make the realization that they looked at and they said, how could that one little peanut have, 2,000 calories? So we talked about that. The calories had to be worked into a more manageable number. We conduct the demonstration with students reading a handout and watch the videos to discuss some concept development as well. And using this knowledge, we discuss which food item was the best choice for packing energy and why is it important to send energy-dense foods to space. So we try to make that connection back to space again, because that's kind of what hooked us. Was your food good for an astronaut? And then now we've learned about food and how it's calculated. And then now we're able to talk about, what was the best choice for packing energy? What is the best choice for that astronaut to eat when they're in space? So in addition to challenging the students to calculate what their daily energy needs are. So while the demonstration hooks the students, I like to use tools like student handouts and teacher slides. Both handouts and teacher slides provide the students with visuals of data tables, discussion questions, and pictures. So you can see in the image next to me, this is an example of a student handout that I would give my students that talks a little bit about daily energy needs, nutrition labels, and they're able to calculate their own daily energy needs. While I also use teacher slides as a guide for myself to help walk through the lesson. This is always helpful for me when trying out new labs or demonstrations. So I encourage you to use tools like teacher slides and student handouts when you're working through demonstrations. Because the goal of the demonstration is to hook the students, but the extra teaching tools can help squash any misconceptions students may have on the topic and help with concept development. I also encourage you to use this demonstration to expand on the topic with larger unit on macromolecules, with the engagement tool of relating it to space exploration. So after I engage the students with the calorimeter demonstration, students can learn about the different types of nutrition in foods like carbohydrates, proteins, and lipids, and start categorizing their own food choices according to the underlying understanding that not all food is equal. The challenges of space are explored through videos and discussion. The students can compare different food options for a space environment, like which choice would be better in space, bread or tortilla, and discuss the reasons why they think bread or tortilla would. So tortilla would be the answer to that because you wouldn't want all the crumbs from bread. The unit that I do culminates with the students acting as food scientists. So now we've given them this place as being a food scientist, this career, and they're engineers, and they're designing a challenge where students create a healthy menu for an astronaut on the International Space Station that meets NASA requirements. So they're using game card pieces, they're reading about carbohydrates, proteins, and lipids, and they're moving these pieces around to make a balanced diet for an astronaut on the International Space Station that gives the astronaut variety while also giving the astronaut nutrition that they need. And then to enhance the experience, I incorporate a STEM career connection with NASA's Surprisingly STEM video featuring a space food scientist. So I'll give you a little preview of this video.
I would definitely consider space food as its own cuisine. On Earth, a cuisine is created when people from a region use generations of wisdom to flavor, to prepare, and preserve the food. And because of unique challenges we're facing for space food, like we need to meet the safety standard, we need to meet the nutritional standard, and the food need to be able to work with a microgravity environment, I think we formed our own cuisine. My name is Shilei Wu. I'm a food scientist by training, working in the Space Food System Laboratory. We create and produce space food for various space programs. I'm the food system manager, so I work.
I hope this demonstration gives you the tools to engage your students in a dynamic and interactive way. This calorimeter demonstration not only brings textbook concepts to life, but also connects them to real-world applications like space exploration. My students left the unit with a wealth of questions and new understandings about food they never had before. Thank you for your time today, and I hope you're inspired to try this in your classroom.